Hi, this is Steve. I made homemade biodiesel fuel, and I followed the instructions in doing this from the website journeytoforever.org. That's all one word, journeytoforever.org. Okay, we are going to measure in the lye. We have potassium hydroxide. Here I'm using a scale, a digital scale that is accurate to 1/100th of a gram, so that's 0.01 grams to which this scale is accurate. And I am using it to measure the potassium hydroxide. Potassium hydroxide is the LYE catalyst that I'm using in this recipe for biodiesel. You always want a lye catalyst, and potassium hydroxide is one of the more common ones. Perfect. And here I have to measure out 5.5 grams, and the scale was able to measure almost exactly to that amount. I got the scale for about $10 on Amazon.com. Methanol, 99% plus, concentrated. I'm going to pour out 200 milliliters into the beaker and transfer it to a container safe for mixing. Eventually I would pour the methanol and the potassium hydroxide into a milk carton, and the instructions require that you pour the two items into a high density polyethylene number 2 plastic container, and most milk cartons would qualify, but any plastic carton that has the little 3 recycling arrows in a circle and then the number 2 in between them, and then the letters HDPE for high density polyethylene. Again, number 2 HDPE containers are okay for pouring in both the methanol and the potassium hydroxide for mixing. Of course, the potassium hydroxide and the methanol are measured out separately first, and when pouring them into the container, you don't even use the same funnel. The instructions said to use one funnel for pouring the methanol into the container, and then a separate funnel for putting in the potassium hydroxide, which you see me doing right now. The potassium hydroxide had to be exposed to the air as little as possible. It can absorb the water vapor in the air, and that can dilute its effectiveness. So the instructions stressed putting the cap back on the potassium hydroxide as soon as possible, and sealing the bag that you store it in airtight, and keeping it in there for as short as possible before putting it into the container with the methanol. You see me doing that here, and that required some care to get the exact right amount into the bag and then pouring it all out through the funnel into the container. Sealing the lid on there tightly. This is our methoxide. So the methoxide is that mixture of methanol and potassium hydroxide. That is what we were making in that milk carton, and you were supposed to stir it, and they do say stirring, not shaking, 5-6 times or so for about a minute each time. After about 10 minutes, the potassium hydroxide is supposed to completely disappear, so it basically is supposed to just look like water. I never got it to completely disappear. The little potassium hydroxide flakes were always kind of there, but I got them to sufficiently disappear that I was satisfied, and I did eventually go ahead with what I had. So that's the methoxide there in the milk carton. Prospects of success for this? So we'll have an update after the long settling period. So a few concluding thoughts on my experiment making homemade biodiesel fuel today, my first attempt. The first thing to note is the cost of it. That has to be factored in. I spent over $120 on equipment to perform this little project today. Now, I pretty much had to start from scratch. I bought that includes a $20 cheap blender from Target, $30 purchasing equipment that includes two very nice glass beakers. One I think that could carry up to a liter of liquid, another about 600 milliliters of liquid, and that includes some goggles, some masks, smaller things like I even purchased sandwich bags and gloves. So a lot of the equipment was reusable. The methanol and the potassium hydroxide were fairly expensive. I got about a liter of the methanol for about somewhere between $12 to $15, and then quite a bit of potassium hydroxide for about the same amount. It's hard for me to say exactly how much fuel I could make using just what I purchased, but obviously the beakers and the blender, things like that, those are one-time purchases that can be reused many times, hopefully, to make many batches. And likewise with the methanol and the potassium hydroxide, there were things that that purchase wasn't all just for this 1 liter. There's still a lot left that I could use to make more fuel at a later time. And at the same time, I do still question. I do still suspect that it could be a cost-prohibitive thing. The vegetable oil you'd obviously have to buy regularly, or you can obtain oil. I think you can get it for free. You can get cooking oil from like a McDonald's or other restaurant. I think you can get it for free. You can get their used oil, but you have to filter it, so you have to clean it. So there's extra work. So even if it doesn't cost something financially, it costs something in terms of time, and time, of course, is money. So there could be a cost-prohibitive factor still that would prevent people living on a very limited budget, which of course is widespread today, from doing this kind of project at home. So that's a major limit, I think. I do think it's doable. I made my one test batch. I'm not sure. I'm unable to test it before I have to submit the project. I'm optimistic that it is something that if you have it within your budget, you could do on a regular basis without too much expertise. You just have to do a little homework, a little reading and stuff, but you don't have to be a chemistry major or something. Any ordinary person with a little bit of time and money could do this, could make biodiesel fuel for themselves, homemade on a regular basis. But I think to a certain point, I think it is cost prohibitive. I'm not sure. I'm suspicious that right now, I don't know that it would be a whole lot cheaper. I don't think, I think that would be a big breakthrough factor if it could actually be cheaper than just purchasing fuel, normal, ordinary, unleaded fuel at the gas station. I don't know that it's there yet. It might be. I did not do detailed calculations, but I don't think that's a factor. I think you'd have to be motivated to do it largely for environmental purposes. So that's a major limit right now to this kind of practice becoming widespread. Another thing I found interesting in my experiment today was having to use methanol. Particularly, I was very struck. I had to pay a lot of attention to the safety precautions that had to go into using it, and I got some mixed messages. Ordering it, first of all, I could not order it. I ordered the methanol and the potassium hydroxide from the same site online, but I had to order them separately. They would not ship them together. They had to be shipped separately and ordered separately. So, and that just kind of gives you a hint about just the kind of precaution that has to go into handling these kinds of chemicals. It's very interesting that it's supposed to be biodiesel. It's supposed to be, very earth-friendly, and yet we have to be very careful in handling it. So it's not in my reading, the impression I got was that methanol is safe for the earth. Like, I mean, you could pour a liter of methanol on into like grass or something, and the earth would absorb it and take care of it, and it wouldn't, you know, it wouldn't be like some sort of biohazard to the earth. But humans have to take great care with it, even though it's a naturally occurring chemical. You know, we have it in our bodies sometimes, and in even some of the foods and drinks that we consume. But you still, when you're handling pure methanol, you don't want to get it on your skin. You certainly don't want it on your eyes, and certainly don't want to consume it through your mouth. And you don't want to inhale the fumes. And an interesting factor there is that in reading up on it, I understand you wouldn't. The level of fumes that you'd have to breathe in of methanol to be dangerous, you would not be able to smell. So you could be inhaling those fumes and not know it. So you have to take some serious precaution. But the website that I used, whose instructions I followed in making the biodiesel, did insist that fear of methanol should not hinder you from attempting this. That you just have to take basic precautions. And as you saw in the video, I didn't go out of my way. I wore ordinary kitchen gloves. I put on goggles. I did put on a little, you know, surgical mask or whatever it was. But I didn't go to extremes. I just took what felt like sort of basic precautions, and I think it did go fine. And the website that I used even stressed that thousands of people have tried this, and to date there've not been fatalities or anything like that. You know, no serious health concerns reported in association with attempting this kind of thing. So there were a little bit of mixed messages in that it seemed like this is both seriously dangerous and at the same time, you know, don't let it stop you. That was kind of the message I got. And I didn't. Another interesting thing though was I used a blender for my test batch, but the website whose instructions I followed recommended that if you go on to make biodiesel on a regular basis, you shouldn't consistently use a blender. You want to create what they called a processor, and I didn't do much research on that. I just used the blender and let that go, so I kind of ignored the processor things. But if you wanted to do this on a regular basis, you would want to create a little homemade processor, which I don't think is super difficult, but it's another step. And another thing was that the creators of the website noted that they extract methanol now without actually pouring it. Like they use ways of extracting methanol from its container, like through a pump or something, so that there's no chance of fumes escaping at all. So there's absolutely zero risk. The instructions said you can pour the methanol, which I did. I poured the methanol out of the bottle, exposed it to the air, but that's the idea, is that if you do it on a regular basis, you want to start getting in the habit of not exposing the methanol to air for fumes, and because I guess that just the air can also dilute the methanol. If you just don't want it to mix with the air for various reasons. So if you do this on a regular basis, you want to do it in a way where you're not exposing the methanol to the air at all. So you need to get it out of the bottle somehow without just unscrewing the lid or something like that. You need to get a pump in there, pump it out, and then transfer it via pumps or other, and which I did not attempt. So I can't report on the difficulty of that, but it is another step. And again, these kinds of little complications can be prohibitive to attempting this kind of thing. So again, it's very exciting to be making fuel. You know, the idea of making fuel that you can put in a diesel engine car and it can be, emission free. That's, very exciting. It's just that there are things, there are some, it's not, you don't have to be a rocket scientist, but there are precautions you have to take, and there's some care you have to take. There's time and money. There's all kinds of factors that I think prohibit this from being the kind of practice that anybody might just want to do on a regular basis. It takes some time, it takes some care, as any, serious worthy undertaking would. It's just something to note for anyone who wants to think about this, that it takes some work and, and it takes some care. So just another thought that I had about this whole process.